Hello everybody, welcome back to Maths Miss Buick. We're still focusing on differential calculus, and in this question we have the function f of x is equal to the square root of 4x over x plus 3, and we're asked to find the value of f dashed to 1. So we're going to differentiate and then put in a value of x. In this case it'll be 1. So let's begin the question by firstly rewriting our function. We know that the square root can be represented by the power of a half. So let's put all of this function here to the power of a half. We can now see that we have the chain rule here because we have a function and it's to the power of something, where the power can be a whole number or it can be a fraction. So we'll bring our half down in front. So now we're going to do our notation f dashed of x to represent that we are differentiating our function. So bring down our half in front. There's our half. Then we leave our function as it is. We reduce our power by -1, which brings us down to -1/2. And then we have to differentiate by the bracket. And you can see here that this part is the quotient rule. So let's do that out first of all on a different whiteboard. So here we go. We have 4x all over x plus 3. So the reason we're differentiating this separately is because, once again, we have to put in the differential of this bracket, which will be the quotient rule. So let's begin by labeling our top numerator as u and our bottom denominator as a v. Let's write out the quotient rule. We have v du dx minus u dv dx all over v squared. Okay, so let's write out our four things. So we have u, we have v, we have du dx, and we have dv dx. Okay, well, our u is our 4x from up here, and our v is x plus 3. Our du dx is when we differentiate our 4x, so we keep the 4 and we lose the x, so we have 4. And then we'll differentiate v to give us dv dx. So if we differentiate x, it goes to 1, and differentiate any constant, it goes to 0. So we can now take our four things which we have worked out and sub them back into our formula. So here we have v, so that's x plus 3, and it's being multiplied by du dx, which is 4, minus u, which is 4x, and it's being multiplied by dv dx, in this case it's 1, all over v squared, which is x plus 3, all to v squared. So let's work out the top line. So we have x by 4 is 4x, 3 by 4 is 12, and we've got a -4x here. And we keep our bottom line. Never multiply out the bottom line, you get no extra marks for doing so. So you can see here that we have our positive 4x and our -4x cancels, and we're left with 12 all over x plus 3, all to be squared. So this here now we're going to put back into our original question up here. So bear in mind, so we had this, so let's rub out the QR, which represented our quotient rule, and let's put in what we have now found. So we have 12 all over x plus 3, all to be squared. So that there is our answer if we don't simplify it down. And what we'll do now for the moment is let's put in our 1 value here, and then we can simplify things. So we have f dash to 1. So we're looking for an answer here to this. So we've got a half, and then we've got our 4 by 1. So we have 4 by 1 all over 1 plus 3, all to the power of -1/2, multiply by 12 all over 1 plus 3, all to be squared. Okay, so we have f dashed of 1. There is our half again. We have 4 all over 4. Of course, that'll be 1 in a moment. Power of -1/2, multiplied by 12 all over 4 to be squared. Let's carry on by simplifying that out. So we have f dashed of 1. There is our half. We know this now here is 4 divided by 4 is just 1. Power of -1/2 by 12 all over 4 squared is 16. So if we go to our calculator and if we type all of that in, so do that here. So we've got 1 over 2 by 1 to the negative 1 over 2. And we multiply that by 12 over 16. So I've literally typed in exactly how I can see it. Hope you can see that there. And here's my answer. So we get 3 over 8. So there we have it. Our answer is 3 over 8.